Okay, I don't actually have to wait for that little timer to go all the way to 0. And I kind of, in a flurry of bad showmanship, I actually showed myself getting ready before I put the countdown screen up. And yeah, I'm sorry about that. I'm sorry. It's supposed to happen in a more organized way, but it didn't. Hey, I'm Eric. I'm animating faces. I'm recognizing speech. I'm combining the things together to make characters that you can talk to. And I'm going to demo what I got going yesterday, and then I'm going to get to work for a pretty short session, like an hour long, something like that. And it's, I'm wearing my day job shirt here, but I'll go down one button just to kind of loosen up a little bit. There we go. Now that's after my day job. I'm getting into the work that I truly enjoy right here, and let's demo. I like to start off with a demo. That's what we're gonna do. Okay, so here's the app. It does a whole bunch of stuff, but my point is to demo what I recently got done. So this animated face, it's gonna have capabilities added to it for speech recognition. Okay. It's a library called Vosk. Actually, it's a library called Kaldi, or a set of tools called Kaldi, which is wrapped by Vosk, which is wrapped by another library called Vosk Web, which is wrapped by my little speech library with specialization, so it's used for storytelling use cases. And yesterday I imported this open source library into my project and got it to detect speech. And so if I say, hey, what's going on? Oh yeah, it's been detecting while I was talking the whole time. So yeah, there's all this speech that's being detected here. So today, what do I want to do in this session? I'm interested in the positions of individual words within the text. It ties into an algorithm I want to create for animating lip movements. So what I'm going to do is create a class in my library specifically for this use case of detecting where the positions of words are inside speech. And I just verified just a moment ago that it's possible to get these starts and ends of individual words. So earlier when I said, hey, what's going on? The result populated by Vosk has got these start and end times in it. So my library, which is wrapping that, I want it to properly collect those things and make them available. So whereas Vosk or Vosk Web is more general purpose, and there's lots of different ways you can use it, the library that I've got is caring about specific use cases and is limiting the options to create like a simplified interface for those use cases. So I've got one class called Recognizer, and Recognizer is waiting for you to say certain words that are part of what the character is expecting to respond to, and it updates as your conversation with the character proceeds, and it matches different words at different points in the conversation. So that interface is very specific to that use case, and that's the value in putting that on top of these other libraries. This other use case I have is given an audio file, not microphone input, tell me the timings of all recognized words in that audio file. So I'm going to make that, and I think I'm going to do it in about an hour. starting now, so it's time to get to work. So I'll come over to my speech library. I got something called Transcriber. I might choose a different name for it. I don't need the microphone stuff in it. So I'll start by deleting all that. I probably don't need this on receive audio thing. Yeah, I'm just going to be calling this accept waveform float thing. Okay, so I'll just start by deleting the code that I definitely don't need. And, you know, that will give me something that's more simplified to begin from. What did I over deleted? Init result it likes. Oh, I know why. Call. Yeah, just basic syntax stuff. Okay. Okay. I just discovered moments ago an undocumented feature of Caldy. If I set the words to true, I get those word timings back, but I wasn't before, so that was a nice little victory. I don't want to use. I do want to use on result. Okay, cool. Transcriber, get rid of the microphone. Okay. I don't think I need bind callbacks. Or at least that's not the best way to do that. I think there's going to be some function like async decode waveform. And then samples, was it uint 8 array? Was that it? I'll find out in a moment. Oh. Okay. What were the samples? No, it's a float. It's going to be... Go back to recognizer. Samples. Recognizer is the other class that works for different use cases. It's a float 32 array. Come back to transcriber. I mean, that should be fine. Let's say decode samples. I suppose this can get set earlier in it. Decode samples. So what are you going to do? You're going to take the Caldy recognizer, pass this in. So we say this Caldy recognizer. I could pass in audio buffer. Okay, where am I getting sample rate from? Context sample rate. Where did I get it from over here? Sample rate. I think I've just got a constant. Yeah, I've got this little note here I want to get from the microphone, but that's problematic. Okay. On receive audio, bam, bam, sample rate. Okay. Let's come back to transcriber. So to do figure out the sample rate, could create a new recognizer based on sample rate of an audio buffer, or resample to match recognizer. Okay, now what's all this? Okay, if it's not defined, throw before recognizer loaded. Okay, this is sample rate. What? That doesn't seem right. Because this was accept waveform float, sample rate. That is what I'm using where over here. That's weird. Okay. Here, let's just do it this way. Yeah, it's right there. So we say samples, which is a float 32 array, and sample rate, which is like that. What the hell? That's quite strange. Okay. Let's finish getting rid of code that I don't need. Don't need mute and unmute. Okay. Quality recognizer. I kind of like using null instead of undefined, or null. And then we will say in the constructor that the quality recognizer is going to be there's some basic syntax issue here. When a bunch of little things aren't working as expected, you just know it's some stupid little missing parenthesis or something. Okay, so let's begin by getting everything to not be an error. Okay. And then add in little bits, one at a time, until the first error is found. I found the error. I just saw it. There we go. Down here, that's still an issue, and I don't get why. Because it's definitely working at the other location. So the Kaldi recognizer. It's saying what? What are you saying? 0 to 1 arguments but got 2. So if I just gave you one argument, would that make you happy? No. Okay, let's do some stuff. Const Kaldi recognizer, Kaldi recognizer equals this. Kaldi recognizer. Okay. What's the issue? Yeah, that's it. Yeah, it's so dumb. Okay, that fixes it. That would be a good example of when dual screen is messing me up. So let's get rid of that for now. Okay. So you accept the waveform float. That will cause onResult to be called if I'm able to set the recognizer inside of here, that would allow me to return a promise. So let's take that out, put it down here. Okay, we'll put the onResult inline. Okay, so okay, then I want to return a promise. This is special kind of JavaScript madness coming up in a second here. So you return the promise. Which is a function, and that function gets passed resolve and reject handlers. Inside of onResult, I pass, or I call resolve. That causes what? Oh, what? Oh, I gotta send something back. Okay, so just for now, I'm gonna say string. Okay, and we'll say result text. Comp. Now this is no longer working. What about if I put up here, now you don't have the onResult there. Okay, what if I take this and put it in here? and let's say if this call do recognizer, or better yet, if not, then reject, and then I can actually just say that. Actually, I liked it better. I had it. Let's do that. Okay, so return that. Oh, come on. I have to do this again. Okay. Let's think this out. We're passing in some samples here. It's an asynchronous function. So it's not going to return a string. It'll return a promise to a string. Okay. If I call this here, that's incorrect. That is incorrect. Okay. Okay, that's totally wrong. I need the event handler to be set before I call accept waveform float. Even if I can get away with it, even if I've tried out and it works, I'm not going to feel confident. So let's say we do this. Okay, then I have the problem that before I'm ready. Call. Okay. So if I do that, then I have the problem. How do I reference the function that'll do the work? It's a useful thing to put inside of this scope for the promise, because that allows me to return a promise and then resolve the promise in the callback. But as soon as I put it inside of here, I no longer have access to that callback in the outer scope. So this inner scope it's correctly off limits. Now if I put this over here, then I'm able to have onResult be called, but I've lost my ability to resolve a promise when it gets called. Okay. There is even another way. Just put everything inside of the promise. Okay. somewhat complex. Promises. So I'm feeling better about this. I think I might follow some good habits I had earlier and set these to private so that they won't be misused. Okay, is ready count being used for anything? I don't think it is. I think I can do better. I can do better than this. Let's go audio buffer. Okay. And I'll get my samples and sample rate directly from the audio buffer. And I can also create a recognizer in response. Okay, so for that, I don't need the init anymore. Well, no, I do need the init. I do need the init for loading the language model. Okay. Okay. Count sample rate equals audio buffer. Audio buffers is what you'd get returned from a WAV file that was loaded as a resource after it gets loaded. I'll return on this one the model. What is the model? What's the it's just model. Okay, promise model. Yeah, okay. Don't need to do that. Oh yeah, I don't even need this. Okay, just return that. Okay. And then sample rate. That's what the recognizer will match. Okay. Get rid of ready count. Model. Private. Don't need that, but do need this. Okay, get rid of that and that. But set the model to null to begin with. Okay. If not this model, return, or actually throw error. Alright, so we set words true. We've got a sample rate that will correspond to the audio buffer. We need the samples. We'll get them from the audio buffer. Const samples equals audio buffer get channel data, and we only want just one of the two channels if it is in stereo. Arguably, I could get both of them and average between the two channels. Okay. This I figured out. And that's verbose. Let's just call it a recognizer. This should be the sample rate. I like how simple this is getting. I guess I don't need this because of how that's referenced. Okay, the next thing is just taking that data and reformatting it in something that's a little nicer. So let's make a new type. What do I want? Type word timing. And I want the word, and I want the time. Or let's see, start time number, end time number. And what I can do is return an array of word timings. Okay, it's going to complain. No, it didn't. That's interesting. When I do this type of promise, it's returned. It doesn't. TypeScript gets lost. Let me see if I can do a generic. That would be kind of cool. Does that work? Ooh. That's pretty cool. I mean, it's still not like checking that resolve is actually word timing, but it's okay. I can deal with that. Okay. This isn't a bad little check here to get rid of like all the empty events. It will send my way. Let's do let's see, return message to word timings. Oh, no, just resolve. Message any and word timing, bam, like that. Okay, this I'll go ahead and export. Okay, so const word timing timings. Now I gotta go back and see what that structure was. Message, result, result. And there's going to be an array. Results equals message, result, result. Let's go ahead and do something like that. If not results, return. I could also just make this code simpler and do, okay, so then we'll do results for each result. Okay, we can return the timings. Okay. What? What? I'm going to get to that. All right. So conf and confidence is that there. Start and word. Okay. Okay. Timings, push. Word, result, word, start, time, result, start. I'm going to divide by 1,000 to just do milliseconds, which is what I tend to use. End time, result, and divided by 1,000. All right, then again, what? What's this? Okay, what's this? I'm probably good with the any type. But you know what I can do? I can create a nicer type. We'll say this is our expected type is going to be, let's see, Vosk word result. Conf number, start number, end number, word string. Okay. Then I can just say that this is going to be Vosk word result. There we go. And there is a type that I can import that should give all this stuff, but it doesn't necessarily match reality. That's why I'm still using any up here. So if I do that, wow. What if this worked on the very first try? Seems doubtful, but it's possible. Definitely wouldn't mind debugging it. But let me just walk through it with my eyes. Okay, you pass in an audio buffer, get the sample rate. If we haven't loaded the model, we throw an exception because the caller should have waited for the onReady to come back and say the language model loaded. Okay, we set the option for words to true, which will give us more granularity on the results. It'll give us this information up here. Okay. Then we insert a bunch of stuff. We put all this stuff inside of a promise. I'm wrapping a callback in a promise. It's kind of a standard technique inside of JavaScript, but it's a little bit weird to the eye, certainly. Reject like that. I think I could just do message as any and then get rid of that ugly thing above. Okay. Okay, if we get a dud message, I'm not going to do any processing on it. There could be multiple results. I don't think that's going to happen though. I think if I pass in a big chunk of samples, it's going to process them all and then return the result. One thing that could change that is if the WAV file's got silence in the middle of it. To do test a WAV file with silence in the middle to see if Vosk passes multiple results. Rather than one. Okay. I think let's round these. Let's do a little function. That's pretty good. It's not bad. Okay. So let's build that, see if that builds. Okay, then I go back to my web app. I need to write some code. First off, let's see, that breaking? Yeah, it did. No bind callbacks. Cool. That's expected. Let's go back to here. go to WebFace, which is the test app. And don't need that. Don't need bind callbacks. Let's see. This is transcriber ready. True. So don't need that. Async. Const audio buffer equals load WAV from URL, and then I'll go get speech mail1.wav. Okay, that's going to be in await. And then const word timings equals transcriber decode samples. I should change the name of that to like decode audio buffer. Okay. And I think I'll just step through this guy. Wait. Let's see. If not transcribe, is transcriber ready? Return. Okay. And yeah, could work. Let's see. Load audio util. Line 14, okay. 14. Wow. App TSX 14. Oh, this junk here. So this should come from how do they do it elsewhere? Let me see. Can I get it from here? I can go to WebFace and put it as an export there. I'll do that for now. It feels like I ought to be pulling out some of those audio things into a separate library, but okay, so if I go load audio util, just load WAV from URL right there. Okay. So then let's add that to what gets exported. Export boom from audio, load audio util. Okay. So I rebuild that library. It's the problem with libraries is it gives you a little bit of friction around making updates because they're in different projects. But it's not too bad. I seem to have gotten to a point where I can update it pretty quick. And that's why I've got all these tabs open. So everything's split across multiple projects. So then go back to web face and we say load web from URL, which is now pulling in. Okay. So if that's there, then if I come back to my, yeah, now we're good again. Okay, let's restart that. Okay, then go to the transcriber. See how I do with this. All right. So we got an audio buffer. It loaded. Duration of it is 2 seconds. One channel, 44100. Cool. Let's go in. Okay, sample data. Do I got it? I got it, and it's clearly populated. Okay. Returning my promise. Setting the onResult handler. I'm curious if it will run to the breakpoint when I click this. I don't think it will. I think there's a web worker and it uses post message to send everything. So I don't think it's synchronous like that. Hit play. Okay, that was only 2 seconds of audio. OnResult was not called. Somebody else had an issue like this. Somebody else did have an issue like this. Let me go and check the... There's my silly question I asked and answered after my own research. This is the Vosk web or Vosk browser project. And let's look at closed as well. Result event not triggered on file upload. Okay, so his problem might be similar to mine. Send the whole file as buffer to the audio streamer write method. Yeah. Okay. So what he did is he called this twice. Okay. And that got the result thing to fire. Okay. Okay. This is probably going to apply directly to me. When you send the audio twice, the recognizer will receive double the audio, and even if there's not much silence at the end of the audio, the length of the utterance is enough to trigger an endpoint detection. Once you have finished sending audio, you should finalize recognition by removing the recognizer with recognizer remove, which will trigger the final result method of loss rate. So it will not be dispatched to the listener as it is removed from the list of recognizers before the event is received. I'll work on a fix. Okay, so Clement added a PR. I suspect there's no version bump on the NPM package. Okay, so just thinking about this a little bit, I can do a git clone of the project and use that source and see if that fix picks it up. I can also try this other thing, recognizer remove. I'm gonna try that first. It seems like a nice thing to have anyways. South web face, let's go to web speech. Let's say recognizer remove. Okay, let's try that. Okay, run the build again on web speech. Come back to here. And I'm gonna just restart that. Okay. Okay. Probably the same issue. $547. Is there some way I can quick hack this. I would just love to see it working. I could throw some extra samples on the end to give it silence. That is a way to do it. Okay, we'll do. Okay. Samples, and then sample rate, then number of milliseconds. I think 1 second of silence should do it, but let's do 2 seconds of silence. M6. Okay, so number of samples. Pad samples equals sample rate times pad M6 divided by 1,000. Okay, let me think about that. I should actually call it pad sample count. Okay. So 41.1 kilohertz if I remember correctly, that means you have 4,400 samples in 1 second of audio. Just find a calculation. Samples in 1 second of audio. Yeah, that's right. 44.1 kilohertz means every second 4,400 samples are required to represent 1 second. Okay, so we come back here. I think this is right. Sample count equal samples length plus pad sample count. Actually, this is much simpler than I'm making it out to be. Let sample I equals 0, sample I less than sample count, plus sample I 4. Yeah, don't overthink it. Okay. Const padded samples. Float 32 array equals new float 32 array sample count. I think that's how it works. And then you can say padded samples sample I equals sample I less than samples length samples I, otherwise 0. Okay. Oops. Sample I. Okay, so that'll pad it. I'll put silence at the end. Okay, pad samples equals what is the thing you're upset about? Oh. Good warning. Good warning. Good warning. Good warning. Okay, then it's also giving me a nice warning this isn't used. I can fix that. Let's try building that. Okay, so it looks like my breakpoints are no longer in the right spot. I'm curious about pad samples. Curious about the recognizer. Coming down here. Start. Okay. Let's see how well this does. Okay, so I expect it to be like 88,000 or 90,000, something like that. Pad sample count. 88,200. Cool. Samples length. I expect the samples length to be around 88,000. 90,000, something like that. Yeah, 91,477. Okay, together they should be 300 something. Sample count. Whoa. Oh, bad math on my part. No, that's right. 176. Okay, that's fine. Pad samples. We create the new float 32 array. Okay, that seems fine. Then so if I look at pad samples, at the beginning, yeah, we've got sample values. Then at the very end, it should just be a bunch of zeros. Yep. Okay, so that's pretty good. Let's hit play. Aha! My hack seems to have worked. Okay, let's check this out. Okay, results. What does results look like? Oh, that's perfect. That's perfect. Could you stay over here? Okay. And then let's see how it works for each timing. this is beautiful. Okay, I would like to get to the end of that. Bam, okay, what does timings look like? Okay, start time and end time are fucked. But, I mean, that's not going to be hard to fix. I said math round sex divided by 1,000. Over here I've got stuff, start and end is populated. So I just need to go times 1,000, not divide 1,000. They don't have it. Okay. I am going to finish this in time. It's quite a bit of work to get done in a hurry. It's a nice result. Okay, web speech transcriber. Okay. Okay. So I do want to just set a breakpoint here so I can see what's up. Okay. Time means I got it. Fucking got it. Beautiful. Oh, this is wonderful. This is really wonderful. Okay, this is the perfect time to stop the stream. We shall stop it. We shall stop it right here.